Hey guys, so the very last thing we're going to study in chapter 2 here before we finish up is absolute value, right? So you have a general idea probably of absolute value just with interacting with numbers. What we're going to do is we're going to solve equations and inequalities with absolute value, okay? So your general idea that you most likely have been taught already is that the absolute value, definition of it would be something like the distance between a number and 0, right? Absolute value of -3 is 3. Okay, there's more of a general definition of it, is the absolute value actually is a formula or a way to calculate the distance between any 2 points on a number line. So the absolute value of A minus B means the distance between A and B on a number line. Okay, so find the difference between A and B and find the absolute value of that, and that is the distance between those 2 points on a number line. So just very quickly, 1, 2, and 3, these easy examples are going to find the distance between these 2 points on a number line using our little formula up here. Okay, so for 2 and 7, we've got the absolute value of 2 minus -7, okay, which is obviously 2 plus 7, which is the absolute value of 9, which we all know is 9. So the distance between 2 and -7 is 9. Now if you went and drew a number line and you counted off from -7 all the way up to 2, you would count 9 little spaces in order to get that distance anyway. So you can test it if you don't believe me. All right, so for the second one, we're going to make it a little more complicated with some fractions. Okay, luckily they have the same denominator, so it's -8/4, which is the absolute value of -2, which we know is 2. And the last one, just a little tricky negatives, minus -41. If you don't need to write it like that, you could go straight to the plus. Obviously doesn't bother me. Okay, so -14 plus 41 is going to be 27. And the absolute value of 27 is 27. All right, so that's simply the easiest thing that we can do from this section. Now, solving equations and inequalities with this, a little bit more difficult. Okay, so I'm going to go through it with this table first, and then I'll actually write out, well, I did write out, go over procedure for how to do this. Okay, so the easiest way to do it is an equation. Okay, so if the absolute value of x is equal to 1, the meaning of this is that the distance between x and 0, right, the distance between x and 0, because it's like x minus 0, is equal to 1. And we know from our basic understanding of what absolute value is that if that's the case, then x has to be either 1 or -1. Okay? If the absolute value of x is greater than 1, that tells us that the distance between x and 0, again, this time is bigger than 1. Okay, so if the distance between x and 0 is bigger than 1, that means that x could either be bigger than 1, greater than 1, okay, or it could be less than -1. Okay, so two options here. In order for this sentence to make true, x is either greater than 1 or less than -1. And lastly, if we have the absolute value of x is less than 1, that means that the distance between x and 0 has to be less than 1. Okay, so that means that x either has to be less than 1 or greater than -1. Right? So that makes it kind of an and problem. One thing to notice here, right? These, anytime your absolute value is greater than a number, always going to be, oh, sorry, that's the wrong thing. Always going to be turning into an or problem. Okay? And this one, whenever the absolute value is less than a number, it's going to turn into an and problem. Okay? So these are conjunctions. The bottom one's conjunctions, and the middle ones are disjunctions. Always going to be that way. All right, quick special examples. This first one here, the absolute value of x minus 3, so the distance between x and 3, is greater than -2. If you say that to yourself, you realize that that doesn't make any sense. If you notice in both of these special examples, we have negative numbers over here. Okay, you can't have negative distances. All right, but for this first one, you notice that it's greater than -2. So the distance between x and 3 is greater than -2. Well, every distance between any two things on a number line is going to be greater than -2. Okay, so this one is going to be all reals, or all solutions. Okay, for the first one. Now the second one looks very similar. Okay, but the obvious distance, or obvious difference, is that we have less than. Okay, so the distance between t and -5 is less than or equal to -1. Well, there's no number, there's no t that you could come up with that would give us a negative distance between that and -5, so that one is going to be no solutions. Okay, so if you're greater than a negative number, it's going to be all solutions. If you're going to be less than a negative number, it's going to be no solutions. Now these steps, right, so this is another way, if the table isn't helpful to you, right, you could follow the step-by-step kind of procedure to follow, to find the solutions to absolute value equations and inequalities. So what we're going to do first, we're going to isolate the absolute value to the left side, so move the absolute value to the left side, and some of them will be already like that, some of them you'll have to work with it. Right, then once you get it like this, then we're going to split it into two equations or inequalities that'll get rid of the absolute value for us. Okay, now getting rid of the absolute value there, okay, the first of the two equations we create, or inequalities, is the exact same as the way it's written, just without the inequality, or the absolute value symbols. And the second one is going to be the same idea, except for the right side, right, the number that all of our absolute values equal to, has going to be multiplied by -1, or you can think of it as change the sign. Okay, for an inequality, on that second inequality that you write, you're going to flip the sign as well. So when you multiply by -1, you'll also flip the sign. And then you just solve each equation or inequality and graph, if that makes sense. Okay, so let's do a couple examples. So this first one, the absolute value is already by itself, so we can just split it right away. Write the first one the exact way it is, just without the absolute values. The second one is the same thing on the left side, but the opposite on the right side, so multiply by -1. Solve both. 2s equals 2, s equals 1, 2s equals -8, s equals -4. So there's two answers to this, s equals 1 or s equals -4. So if you had to graph this, you'd have 1, you'd have -4, fill that one in, fill that one in, and that's it. Okay, I'm not going to graph the other equation. Those graphs are not very interesting. Okay, the inequalities are the ones that I'm worried about for graphing. Okay, so this one, once again, is already set out for us. The absolute value is isolated, so we can go straight to the split stage. The same way it is, same on the left, opposite on the right. Okay, solve for x, so we can subtract, divide by -1, subtract, divide by -1, and our two answers are 3 and 7. Number 6, okay, now we'll get to the more difficult ones with the inequalities, okay? So this one's already set up for us. We can go straight to the splitsies. That's great, 3 minus k. Now we flip the sign and multiply the right side by -1. Okay, so notice that the left side stays the same for both of them. For the first one, same sign, same number. Second one, opposite sign, opposite number. All right, now we'll solve. So -k is less than -1. K is greater than 1. Okay, and -k is greater than -5. And so k is less than bad k, really bad k. Okay, that's a k, less than 5. Okay, that's what we have. K is greater than 1. K is less than 5. All right, so because of that, all right, for these problems, you remember how I explained that usually when you shade in between, it's an and problem, and usually when you shade the outside, it's an or problem? For these absolute value ones, it's always that way. Okay, so for this one, we're going to be shading in between 1 and 5. Open circles at both. So greater than 1, less than 5. So it's an and problem, you just shade in between. That's what it looks like. Okay, number 7. Here we go, now we're going to get a little bit more interesting. Okay, so for number 7, right, we need to isolate the absolute value to the left side first before we do anything else. So we need to add the 5 or subtract the 5 halves and subtract over the well, I guess what we could do is let's just subtract the 1. This might make a little bit more sense. So we'll subtract the 1 first. So we have 3 halves is less than or equal to absolute value of 2 plus 1 half x. Alright, so let's just write that in reverse order before we split. So absolute value of 2 plus 1 half x is greater than or equal to 3 halves. Alright, you could of course get the absolute value to the left first, and then get the 5 halves to the right, and then divide by -1 and flip the sign, and you get the same result anyway, but this works either way. Okay, so the first one, write it the exact same way it is, without the absolute values. Second one, same idea, but flip the sign and make the right side negative. Negative 3 halves. Okay? Solve both of them. Okay, so in order to solve both of them, we'll actually take a quick look just so we know we can figure out if it's an and or problem right away. Alright, so if you have it looking like this, absolute value greater than or less than a number, a positive number. Alright, if it's greater than or equal to, it's going to be an or problem. Okay, because the distance has to be greater than 3 halves, so it's going to be 3 halves up and on forever to the right, and then negative 3 halves and to the left. Right, and for if it was the opposite, if this was less than or equal to, then it would be the in-between part, an and problem. Alright, so that's a little trick that you can remember. Subtract over the 2. Negative 1 half. Multiply by 2. X is greater than or equal to 1. Negative 1. Yeah. Okay, and on the right side here, subtract the 2 again, and we'll get negative 7 halves multiplied by 2, less than or equal to negative 7. Okay, to graph it, we've got 0, negative 1, negative 7, close circle of both of them. It's got to be greater than or equal to negative 1, so shade to the right, less than or equal to 7, shade to the left. It's an OR problem, and that's what it looks like. Moss on the back. So on this last page, we've got a couple more interesting problems. So this first one, we need to isolate the absolute value first, so divide by 3. Then we can split, and we'll get 2w minus 5 is greater than 7, and 2w minus 5 is less than negative 7. Solve for w. W is greater than 6, and 2w is less than negative 2, w is less than negative 1. Okay, so greater than 6 and less than negative 1 means it's going to be an OR problem. We're going to shade on the outside, open circles, and that's what the graph will look like. Now number 9, alright, we need 2 steps to isolate our absolute value. First we have to add the 7 of 5. Absolute value of 6 plus x is less than or equal to 34. Then divide by 5, 6 plus x is less than or equal to 34 over, that's supposed to be a 4, over 5. And now we can split. We'll split to 6 plus x is less than or equal to 34 over 5, and 6 plus x is greater than or equal to negative 34 over 5. Okay, subtract the 6's. Get 4/5 and negative 64/5. Okay, so we're going to be less than 4/5 and greater than negative 64/5. This one's going to be a little bit not to scale, but we've got closed circles at both, and we'll shade in the middle in order to graph that. Now lastly, number 10 here, I'm just going to get you started, and then you guys are going to go ahead and finish it. Okay, so for this one, all right, we actually have to treat this as 2 separate inequalities. We'll do this one first, but I'm going to write the absolute value on the left greater than 1, or 2x plus 1 is less than 3. Okay, so those are our 2 things. Now this is a conjunction, alright? So now we need to split both of them and then solve and graph, alright? So give that one a shot and we'll go over in class.